Hi everyone, welcome back to the channel. So today we will be discussing another problem from our SD sheet, and we were discussing questions from dynamic programming. So I'll show you the problem statement for today, which is maximum sum increasing subsequence. Okay, so this problem is going to be very easy for you if you have already gone through longest increasing subsequence. That is one problem that we have already solved. Let's understand what we have to do here. Given an array of positive integers, find the sum of the maximum sum subsequence. Okay, so let's directly move towards it. Let me take this example. I'll check if I'm live. I think we are. Okay, 1 1 0 1 2 3. So the array that we have is 1 1 0 1 2 3 and what else, 100. Okay, fine. So guys, you already know what a subsequence is. A subsequence is obviously collection of series of these integers that we have, and they need not to be consecutive, correct? Okay, and going back to the brute force approach, which we already discussed multiple number of times, one way would be to go ahead and check all the subsequences, find their sum and check which is the maximum. Obviously we're not going to go that way, and the reason also you know why. Now let's come back to it. So if you want to relate it to the problem that we did, longest increasing subsequence, so what we wanted was, we were keeping a track of what we found so far. Let's have a look. So here I have, let's go one by one. What is the sum so far? If my index is at this position, if I'm here, what is the sum so far? It's 1. Okay, fine. Now when I come at this index, what will be the maximum sum subsequence? So first thing is, check out the possibilities. 101. Okay, this array that I'm filling right here, it will ideally tell me what is the maximum subsequence till this index. Okay, so for that I have to check if this number is greater than the numbers that I have found previously. Okay, so right now I have just found one number before it, and I can definitely make a subsequence out of these two numbers. And if I make a subsequence out of these two numbers, my sum will come out to be sum of all these numbers that I have in the series, so that will be 102. Okay, let's go back to the other index. Now when I'm at this index, I have to check what are the possible subsequences I can find by inserting 2 in the end of that series. So I will check what all subsequences I can have right from the starting index. So first thing, when I'm at this position, can I add 2 after 1? Can I make a subsequence like this? Yes, it is valid. Why? Because I want an increasing subsequence. So this number should be greater than any number that you are considering in the subsequence before it, right? So if I consider it, tell me one thing. This is something that you have to check. You have to go back in the loop, starting from the 0th index till I minus 1th index. One by one you check if that number is greater than the current number. Then you ask this array, okay, that what is the maximum subsequence for this index so far, right? Because I am creating this array, it is taking care already that whatever sum I am getting at these indexes, this is actually making sure that it is the max sum subsequence till that index, sum subsequence till ith index, where the jth, or you can say jth idx, wherever I am. Okay, so I can definitely insert it after 1, and the sum that I'll get will be 3. But is it the maximum subsequence which I can create with 2? Let's check. Now I am at this index 101. I'll check, can I insert 2? No, definitely not, because 101 is greater than 2 and it will not be an increasing subsequence. So the maximum sum that I can get when I am at this index, so basically 2 can create a subsequence which is 1 and 2, and the maximum sum that it can produce will be 3. That's all. Okay, fine. Going on to the next index. Now when I have 3, I want to find out what are the possible subsequences that satisfy our condition can 3 create or form. So I'll go back to my 0th index. I'll check, can 3 form a subsequence with 1 in it? Yes, it can be a subsequence like this. So for that I will check that this array is giving me a sum of 1. So if I add myself to it, my sum will become 4. Is it maximum so far? We'll see. First sum that I got is 4. Now I move my index to the next one. I see 3 cannot create a subsequence with 101, right? It's not possible, but because it is not an increasing subsequence. So definitely no answer from here. Can I create a subsequence with 2 in it? Yes, I can. So I will ask my array that what is the maximum sum that 2 can produce from its subsequence. It says it can produce 3. Okay, so I don't have to worry about what is that subsequence. I am already, this is what DP is supposed to do, right? It is supposed to store the answers which we are calculating one by one for the smaller sub problems, and making use of that I'll create my own answer. So 3 will be added to this number, so the sum that I'll get will be 6. Is this 6 greater than my current value? Yes, it is. So my sum for subsequence that I will find from 3 will be 6. What will that subsequence be? That we don't have to return, but you know how and with what numbers it is creating that subsequence, which is giving me a sum of 6. Let's check about 100. So 100 is obviously greater than everyone, so it can be added after everyone. It can create multiple subsequences. I just have to check which will fetch me the maximum sum. So if I insert it after 1, I'll ask my DP array that what is your answer. It says I can only create a subsequence with maximum sum 1. Okay, if I add myself, my sum will become 101. Let's see if it is the maximum. I go to the next index. Here 100 cannot be added, sorry, after 101 I cannot add 100, so not all the integers are applicable here. So this is not possible. Move to the next index. Definitely I can create a subsequence with 2 and 100. So the sum that I'll get will be the sum that I am getting with 2 as the last number of my subsequence, and then I add myself, so my sum will become 103, and this is going to be the greater one as compared to 101. Okay, then I move to the next index. Can I add myself after 3 to create a subsequence? So whatever subsequence 3 created, I am adding 100 after that in my subsequence. So I have to check that whatever subsequence 3 was part of, what was the maximum sum it was giving. So I'll get that answer from here. I'll add myself to it, so the answer I'll get will be 106. So you can see from among all the indexes, the maximum answer that I'm getting is 106. It is not necessary that I'll get it at the last index, okay, since you might confuse, because like yesterday the question that we did, we were getting our answer in the last cell. So you don't have to memorize these things, that if any particular cell will give me the answer. You just need to understand the concept that we have to find the maximum sum. So that I'm getting as 106, which will be my answer. Got it? So that's pretty much about it. If you guys have any doubts, you can ask me. So what are we going to do? I'll just write the pseudo code for you. So basically, I am creating an extra array. Let's name it as DP array of same size as your given array. Okay, for example. So I have this array, right? I will pre-fill this array. Either you can pre-fill this array with integer.min value, okay, initially, or since in the worst case also, one number I am always going to get a subsequence of at least one integer, right, which is the part of my array. For example, I have an array like this 1 2 3. Even if I want to compute my DP array which I am creating, the minimum that any number, the minimum sum that any number can give me will be the number itself, right? So you can pre-fill this array with the original integers that you had in your array, right? And then if whatever will be the maximum will be updated here. And how you are going to calculate the maximum, that is, you check for, there's an outer loop starting from 0, I less than n, I plus plus, right? Okay, then you move from for int j equal to 0, j less than I, right, j plus plus. Your target is to find if your current value, if ARR of I with wherever you are, if it is greater than ARR of j, which is the preceding index, right? If it is greater, that means you can definitely create a subsequence with it. Now the answer that will be in your DP of I will be max of whatever is the current value, okay, and the value that you will get after adding that ith value in your subsequence. subsequence, right? So for that you need to know that jth index subsequence was giving me what sum. So that you will get from dp of j. This will give you the answer that I was getting when that jth index was the last number of my subsequence. So that sum plus myself into it will be the total sum of that subsequence plus ARR of I. So whichever will be the maximum value, I'll update here. And after this second for loop, right? For example, this is for the second for loop. When you come out, you are also simultaneously keeping the track that whatever finally is in your DP of I, right? Whatever is in your DP of I, you also have to check which is the maximum in that particular DP array, right? So I'll just keep updating my answer. I'll take an answer initialized to min value. Answer will be max of the current answer and the final DP of I, whatever I got after computing it up from above, right? So that is pretty much about it. That's all. Simple two for loops, definitely big of n square, but you know from where till where we have optimized it, right? So this is what I discussed. Exactly, there's nothing more to code. That is why I'm not shown you enough. So that's all about today, everyone. Let me know if you have any doubts. Otherwise, we will wrap it up. Okay? Fine then. That's all for today. See you all in the next lecture. Bye bye and take care.